A relation is a set of pairs of input and output values. You can represent a relation in the four ways you're going to see up here. First way is by listing the ordered pairs, the XY values. So a relation is simply what you're used to in Algebra 1 as the set of XY values. Also known as the input and output. The X values are the input, the Y values are the output. So that is one way to show a relation is by listing the ordered pairs. Another way, not so common, is by a mapping diagram where you map the X values to the Y values, or the input is mapped to the output. Another, this one you are familiar with, is a table of values. You've done these in Algebra 1 where you make a table of values. Usually the X is on the left, the Y is on the right. You put X values in and you get out Y values. Normally you were putting X values into an equation and getting out Y values. And finally, by a graph, where you're graphing the XY coordinates. So those are the four ways that you can represent a relation. By just listing the ordered pairs with a mapping diagram, by a table of values, and then also by a graph on a coordinate plane. Some key words here that you have to remember, starting with the domain. The domain of a relation is the set of inputs, also known as the X values or the X coordinates of the ordered pairs. So you have to relate that the X coordinates are also known as the domain. When someone says the domain, they're talking about the X coordinates or the inputs. So domain, inputs, X coordinates, those words all mean the same thing. The range is the set of outputs, also called the Y coordinates of the ordered pairs. So those words you have to relate together and understand they all mean the same thing. Range, outputs, Y coordinates. So the Y coordinates are the outputs. You put X in, you get Y out. But the Y coordinates are also known as the range. So the domain is a set of X values. The range is the set of Y values. So if you're asked in the following relation, what are the domain and the range of this relation? So you have a set of XY coordinates. You need to state the domain and the range. So the domain is simply the X values. So if you're asked to state the domain, you would just list the X values. You have X values of 1, 2, 3, 5, and 8. So the domain consists of 1, 2, 3, 5, and 8. As far as the range goes, that's simply stating the Y values. So the range consists of 4, 9, 12, 17, and 21. Again, I stress, the domain is the set of X values. The range is the set of Y values. Always remember that. So people get confused on what the domain is versus the range. One way, simple way to remember the domain is that in the word domain, the word in is in both the domain and the input. So if you can relate that the X coordinates are the inputs, then you can also relate that the domain is the X coordinates, which is the inputs. So domain, input, X coordinates, those all mean the same thing. Remember that. Also the range, it's the outputs, also known as the Y coordinates. Always remember those things. It says, what is the domain of the relation given by the ordered pairs? Remember, the domain is the set of X coordinates, also known as the inputs. So the X coordinates listed here are 2, -4, -2, 3, and 2. Now the 2 does show up twice up there, but you don't need to list it twice when you're stating the domain. So we're looking for one of these answers that has a 2, a -4, a -2, a 3, and once again, you don't need to state the 2 twice. So the best answer would be letter G. Now that doesn't match the order that we have them in, but you notice they are listed in order going from negatives to positives. So -4, -2, 2, and 3, that is the domain. Another key word you need to remember is a function. A function is a relation in which each element of the domain corresponds with exactly one element of the range. Think about what those words mean. Domain is the x values. Range is the y values. It says each element of the domain, in other words, each x value, corresponds or points to or matches up with exactly one element of the range or one y value. So once again, each x value matches up with or points to exactly one y value. So you're asked, is this relation a function? Does each x value match up with or point to or correspond with exactly one y value? So the -3 points to the -2, the 0 points to the 7, and the 4 points to the 1. In other words, you input -3, you get an output of -2. You input 0, you get an output of 7. You input 4, you get an output of 1. Well, each x value matches up with or points to exactly one y value. So to answer the question, yes, that is a function. Each x value matches up with exactly one y value. Next, is this relation a function? 4, -1, 8, 6, 1, -1, 6, 6, and 4, 1. Look at that. Does each x value match up with or point to exactly one y value? You cannot have an x value that matches up with or points to two different y values. That's not a function. So you see the 4 matches up with -1. The 8 was 6. 1, -1, 6, 6. But notice we have another 4 matching up with, this time, a +1. So you have an x value of 4 matching up with or pointing to two different y values. For the input of 4, you have two different outputs. That makes that not a function.